Welcome to this channel, Chemistry Made Easy by Dr.Ashok Mulik. Today we will discuss the new point in the topic is ionic bonding and structure. Today's point of interest is Fajan's rules. So Fajan explained these rules in order to provide explanation for ionic solids which show the unexpected behavior. So what is unexpected behavior? Generally, if we consider just a few characteristics of ionic solids, that the ionic solids are characterized by its easy solubility in water, that is great solubility in water. Similarly, the melting and boiling points of ionic solids are very high. So if we consider such type of properties in every ionic solid, then we find that most of the ionic solids do not exhibit such standard ionic characters, that is very high melting points and boiling points. Similarly, the electrical conductivities and colors. So the ionic solids are expected to be colorless, but some ionic compounds exhibit colors. So such unexpected behavior is explained by the Fajan in order to provide better explanation. So for this purpose, he considered the basic concept, that is polarization of anions by cations in ionic solids. So if we consider the ionic solid, so this is the cation, and this is, say, the anion. So this positively charged nucleus is there. This is the positively charged nucleus, and the surrounding circle indicates that the electron cloud. So if the ionic compound is pure or 100% in nature, that is ideal, we can say pure. If the ionic compound is pure or 100%, then the size of cation and size of anion remains unaffected. That is, the cations and anions are having completely spherical structure or shape. But in actual structure of ionic solids, we find that in some cases the cation has nuclear force of attraction exerted on the electron cloud of the anions, and this cation, this nuclear charge also exerts electrostatic force of attraction on this electron cloud. As a result of this, the electron cloud of anion is pulled closer to the cation. So we can show this delocalization of electron cloud, that is, we can say delocalized electron cloud. So that is deformed. So this type of delocalization takes place due to the attraction of electron cloud by this cation. So such type of delocalization introduces the covalent characters in ionic solids, because the electron cloud is shifted towards cation. So this migration of or delocalization of electron pair or electron cloud from anion to the cation is responsible for introducing covalent characters in the ionic compounds. So this behavior will be explained in 3 parts or in 3 points. So we will see these 3 points here. First point is the size and charge of cations. Size and charge of cations. If we take the cations and anions of suitable nature, then we can discuss the properties or effect of the ionic solids on the covalency. So with reference to the size, we will take the example of some cations, that is Be2 plus, Mg2 plus, Al3 plus and Sr4 plus. So these are the some cations which can exhibit the effect. Then we find that these cations are having increase in size and charge. There is also increasing size and charge. So here Ba2 plus, Mg2 plus, and we will consider the cations of same charge, Be2 plus, Mg2 plus, Ca2 plus, Ca2 plus, Sr2 plus and Ba2 plus. So this will show size increases in this direction. Size increases. So with this increase in size, the covalent characters decreases. The covalent characters are found to be decreasing, and with this direction we can show the melting points and boiling points are found to be increasing. So this shows the effect of size of cations on the covalent characters that are exhibited by the ionic solids. So with when the size is smaller, it has very strong ability to polarize the anion. So this ability goes on decreasing with increasing size of the cation. Now we will see the example in which we are considering charges, charge on the cations. So for this purpose, if we take Na plus Mg2 plus, Al3 plus and Sr4 plus. So with this we can consider the effect. So you will find that the charge is increasing in this direction, and on this basis we say that due to this smaller charge, the ionic characters are larger. Means with increase in the charge on the cation, the covalent characters increases. So charge is increasing in this direction, and we find that the covalent characters increase. In this direction. So compared to Na plus, the Si4 plus compounds are more covalent in nature. So their melting points and boiling points are lower, or we can say the solubility in water is also decreasing in this direction, and the various other characteristics are of covalent nature as we move from left to right in this series. Now we will see the next example in the form of its second point. That is size and charge of anions. Size and charge of anions. So here, if we consider the series of examples in which we say NaF, NaCl, NaBr, NaI. So here, NaF has the anion. We are considering only anions because Na plus, the cations are same. So the covalent characters depend on the effect of size. So size is increasing, size of anions is increasing in this order. So with this increase in the size, the covalent characters also increase. So size is increasing of anions. So because of this, the covalent characters increase in this direction. So because of this, we say the this NaF is most ionic in nature, whereas this NaI is said to be most having more covalent characters. So in this way, the size of anion increases in this direction and covalent characters also increase. So it means melting and boiling points are more in NaF, NaCl and decreases in this direction. Then we can consider another series in which we will find that the charge is increasing, such as HF. Here F is -1. So F has -1 charge. Then we will see H2O, then NH3 and CH4. So here we show that the F has -1 charge, oxygen ion has -2 charge, this nitrogen has -3 charge, carbon has -4 charge. So charge of anions is increasing in this direction. On this basis, we say that with this increase in the charge of anions, the covalent characters increase. Covalent characters increase in this direction. As a result of this, the melting points, we can consider the melting points and boiling points decrease in this direction. So the characteristics of ionic solids are not exhibited everywhere in the same amount. These are varying with decreasing characters from HF to CH4. Here HF is most ionic in nature. Then the covalent characters are more compared to this HF in H2O. These are shown here that NH3 is more covalent than H2O. CH4 is most covalent in this series. So these are some examples in which we find that the effect of size and charge of anions on covalent characters of the ionic solid. Now we will see the third point, that is 8-electron system. 8-electron system and 18-electron system of cations. applications of cations. So cations having 8 electron system means the cations in the valence shell has 8 electrons, only maximum 8 electrons. So the d electrons are upside. D or shell, we say the shell is upside or the orbital is upside. Orbital is upside. Here in this 18 electron system of cations, the d orbital is present. So we can have the examples of such d orbital of say, that is cations, that is says sodium, that is Na plus, H plus, Li plus, Mg 2 plus, Al 3 plus, etc. So these are various examples in which we find that the valence shell has no d orbital. So such cations will exhibit the more ionic characters. More ionic characters means their covalent characters are less. That is less covalent characters. On the other hand, you will find that these 18 cations with 18 electron system which contain d orbitals shows more covalent characters. So they show more covalent characters. Means less ionic characters. So we can have the examples such as the compounds containing calcium, strontium, barium, silver, that is Ag plus, or we can say silver compounds, or many other compounds of this type in which the d orbital is present. If we consider the say chlorides of AgCl or say copper, iron, etc. So we can also consider the FeCl3, for example, which is also containing d orbital. So FeCl3 is less soluble in water because it has more covalent characters. Similarly, AgCl, barium chloride, etc., or strontium or calcium chloride. So these are having less solubility in water, indicating that it is more covalent in nature. So all such systems, 8 electron systems and 18 electron system cations, shows different covalent characters and ionic characters. So this behavior is explained by Fajan. And now, so we will stop here, and in the next lecture we will see the applications of Fajan's rules. So thank you very much. Till then, goodbye. So please subscribe to this channel, press like button and bell icon button. So see you next time. Thank you.